All right, first types of questions we have are the interest questions. So it says Lauren initially invested $1,580 into her savings account. The interest rate on this is 2.35%. How much money is in the account after 6 years? Use the following conditions to evaluate. So let's solve when it is quarterly. So yesterday we said quarterly, N is 4. We still have to figure out what P, R, and T are going to be. What's our principal? 1,580. What would our rate be? 0.0235. Perfect. Since it was 2.3, we moved the decimal twice to make it the decimal version for our rate. And then what's our time? 6. So let's plug that all into our formula. We have A is equal to 1580 times 1 plus, Maya, question? 0.0235 over 4 to the power of 4 times 6. On the quiz tomorrow, I want to see what you're putting in the calculator. I want to see this part. So the formula with everything plugged in. 4 comes from quarterly.
What makes it quarterly?
Like it said quarterly, so we had to find quarterly, monthly, and what was the last one? Weekly.
Yeah.
So that'll always be like in the question one of those words, and you just have to figure out based off of those words what your N is. So if it says quarterly, we have 4 quarters in the year, so N would be 4. If it says weekly, we have 52 weeks in the year, so N would be 52. Monthly, N would be 12. What about daily? 365. Annually would just be 1. And semi-annually? Semi-annually would be 2. So these are keywords that you would see. So it would have these in the question. You just have to know what N is depending on the words. All right, so let's plug this onto our calculator. I always like to do the exponent first. So 4 times 6 would be 24. And then we can do inside the parentheses. So inside the parentheses, we have to divide before we add. So 0.0235 divided by 4. And then plus 1. You'll get 1.005875. Keep it in your calculator. For all of this, you can keep it in your calculator. You don't really need to write anything down. I write it down to show you what you can get in each step, but everything can be kept in the calculator. So then we're going to raise this to the power of 24. So you should get 1.1509. It keeps going, but we're going to leave it in the calculator and then just multiply that times 1580. So we should get our amount is 1,818.50. So whenever they're talking about dollars for the interest questions, you always just round to 2 decimal places. So that would be our answer for A. All right, next let's find when it is compounded continuously. So anytime you see the word continuously, you have to use your PERT formula. A is equal to P times E to the power of RT. So our P, R, and T stay the same from the question above, but we're using our PERT formula. So I'm going to do it on the side over here. So our amount is equal to 1580 times E to the power of R times T, so 0.0235 times 6. So I'm going to do 0.0235 times 6. We get 1580 times E to the power of 0.141. Juan, what is E? The button in your calculator.
Yeah.
Perfect. The last class asked me, what do I plug in for E? Nothing. It's the button in your calculator. So E to the power of 0.141 will be 1.1514. It keeps going, so keep it in your calculator. Multiply it times 1580. We get 1,819.25 and 25 cents. So this is when it's compounded continuously. You're going to use your PERT formula. Good with this one? All right, next, when it says evaluate the following, we are plugging it into our calculator. I'm going to do B for number 2. So we have negative 4 times 1/3 to the power of 2/3 plus 1. Make sure you follow your order of operations. You have to do PEMDAS. And then whenever you plug a fraction in the calculator, they have to be in parentheses. So I'm going to do 1/3, but 1/3 is going to be in parentheses. So parentheses, 1 divided by 3, parentheses, to the power of, and then again in parentheses, 2 divided by 3, parentheses, equals. When you put that in your calculator, you should get 0.48. It keeps going, but just leave it in your calculator. Multiply it times negative 4. So you should get negative 1.92299. It keeps going, and then just add 1. So it would be negative 0.922999. On the quiz, it'll be specific on how many decimal places. I think each question says 5 decimal places, excluding the money one. So we have 1, 2, 3, 4, 5 decimal places. 9 tells us that we round up or keep it the same. Round up. So since we are rounding up, that would make this 10, which would actually make the next one 10, which would make the next one 3. So this would be negative 0.92300. So this would be our answer. All right, for number 3, let's look at C. So here I'm going to plug in square root 2. So I have negative 2 times e to the power of negative square root 2 plus 3 minus 5. So we have to follow PEMDAS, but because we have multiple things going on in the exponent, we treat that as if it's in parentheses. So we have to do the stuff going on in the exponent first. So it'd be negative square root 2 plus 3. When we put that in the calculator, you should get 1.585. It keeps going, but I'm going to leave it in the calculator. And then do e to that power. So second e, and then I can keep that answer in my calculator. So I have negative 2 times 4.88. It keeps going, but I'm going to leave it in the calculator. So times negative 2, and then minus 5. So you should get negative 14.766260. 0 tells me that I round up or keep it the same. Keep it the same. So that would be our answer. All right, next. It says describe all the transformations. So we have to identify the transformations of everything except the base. We ignore the base. So you can just cross off the base, scribble over whatever your base is. That is not a transformation. It's going to be some number, could be a fraction, could be a whole number. It doesn't matter. That is not a transformation. The base is not transformation. So when we multiply a negative on the outside, what does that do to our graph? Reflection on the x-axis. What about multiplying it by 3/4 on the outside? It would be a vertical shrink. Outside is vertical. Now inside, we don't have parentheses here, but whatever's in your exponent kind of acts as if it is in parentheses. So whatever is happening in the exponent, that would be as if it's in parentheses inside. So if we were multiplying by a negative on the inside, what does that do to our graph? reflection on the y. And then when we add 2 on the inside, left 2, and then subtract 8 on the outside, down 8. Awesome. All right, let's do the next one. So again, the base is not a transformation. Just scribble that out. You're not doing anything with the base. It is not a transformation. And then whatever's in your exponent, that acts as if it's in parentheses. So when we're multiplying by 5 on the outside, what does that do to our graph? No, reflection's only when it's a negative. Vertical stretch. It's greater than 1, so it is a stretch. What about when we multiply by 9 on the inside? Horizontal shrink. Perfect. When it's inside, it's the opposite of what we think, so it's a horizontal shrink. And then subtracting 1 on the outside? Down 1. All right, next page. So we talked about these a little bit yesterday. You don't have to graph, or you will not have to graph on the quiz, but it is important to know what the graphs look like to help you with your domain and range. So I would recommend sketching the graph just so you know what your domain and range is going to be. So for number 7, is 7 going to be exponential growth or decay? And how can we tell? How is it? Why do we know that it's decay? Our base is less than 1. So this tells us that it is going to be exponential decay. So my graph would be decreasing like this. Now, first thing we do is have to check if it's growth or decay. Second thing we have to check for is if we have any reflections. So when graphing, first thing we want to do is check for growth or decay. Second thing you want to do is check and see if you have any reflections. So looking at our equation, we have a negative being multiplied directly to the x. So that is a reflection in which axis? Reflection in the y-axis. So our y-axis is here. So it's going to act as a mirror. So that flips our graph. So it'll be like this. So our graph flips along the y-axis. So now we're looking at the purple graph. So I'm going to erase the blue one just so it doesn't confuse us. So this would be our graph of the function. There are more transformations here, but you don't need to graph them. Just make sure you know if it's growth or decay. Graph that and apply the reflection. Now let's talk about our domain. What would our domain be? Negative infinity to positive infinity, perfect. And what would our range be? So be careful, the range changes if we are moving our graph up or down. So since I have that +2, that means that we go up 2. So our range would be from 2 to infinity. Our graph is going up to infinity, so we know that it's to infinity, but it starts at 2. So anytime, yesterday I said, if there's a shift up or down, then the number changes for range and for horizontal asymptote. So this applies to both the range and the horizontal asymptote. So because we moved it up 2, our range went up 2. Now what would our horizontal asymptote be? Y equals 2. So it's going to be the same number from the range. And then how do we find the y-intercept? Plug 0 into x. So we have 5 times 2/3 to the power of 0, -0 minus 4 plus 2. So So just like before, be careful when plugging this into your calculator. Make sure you follow your order of operations. So I'm going to do the exponent first. Negative 0 minus 4 would just be negative 4. So we have 2/3 to the power of negative 4. When I put that in my calculator, I'm going to put 2/3 in parentheses. Anytime you're putting a fraction in the calculator, put it in parentheses. So 2/3 to the power of negative 4. You'll get 5.0625. Then we multiply that times 5. And then plus 2. So you should get 27.3125. Our y-intercept has to be an ordered pair. The value we found is the y. So our y-intercept would be 0, 27.3125. All right, let's look at the log. So same thing with our log graphs. We always want to start by graphing. Our log graph is just a sideways version of our exponential graph, but it starts in the positive x on our coordinate plane. Now we always want to check and see if we have any transformation. So this is how it starts. This is our basic log. Let's check and see if we have any reflections. We have a negative on the inside of our parentheses. What does that do? Reflection on the y. So my y-axis is the vertical line here. So if that was our mirror, our graph is just going to switch to the other direction. So it would go this way. So this is showing the reflection on the y. So we're not looking at the basic log anymore. We're looking at our orange graph. So now our domain, remember domain is left to right. So is our graph going to infinity or to negative infinity? Negative infinity. So our domain would start with negative infinity. And then the number that comes from the domain and the vertical asymptote, we set the parentheses equal to 0. So I have negative 5x plus 12 equals 0. And we just solve here. So I'm going to subtract 12. Negative 5x is equal to negative 12. Divide by negative 5. So x is equal to 12 over 5. So our graph's going from negative infinity to 12 over 5. Looking at our graph, Tomas, what's our range doing?
Our range is going to be
negative infinity to positive infinity. Perfect. And Tomas, what's our vertical asymptote? X equals 12 over 5. Awesome. Good job. Let's do number 2. So we have exponential. Is our exponential graph here growth or decay? How do we know that it's decay? The fraction as our base. So you always look at the base to tell if it's growth or decay. So this would be decay. So it is decreasing. Do we have any reflections happening here? Any negatives being multiplied outside or inside? No. So this would be our graph. So what's our domain? Negative infinity to positive infinity. What would our range be? Negative 6 to positive infinity. Perfect. Our graph is going up to positive infinity. And then you always look at if your graph shifts up or down. This number tells you what your range is going to be. What's our horizontal asymptote? Y equals negative 6. Perfect. Same number from your range. Repeats in the horizontal asymptote. And horizontal lines touch the y-axis, so it'll be y equals. And then how do we find the y-intercept? Plug 0 into x. So I have 5 times 1/3 to the power of 0 plus 1, which would just be 1, minus 6. So this would actually be 5 times 1/3 minus 6, because 1/3 to the power of 1 is still 1/3. So 5 times 1/3 would be 1.66 repeating, minus 6 would be negative 4.333 repeating. So our y would be 0, comma, negative 4.333 repeating. You don't have to graph, but like I said, it helps to just like quickly sketch it, just so you know what your domain and range are going to be. Because for this one, we knew that our range was going to go up to infinity because our graph's pointing up. So it helps to just roughly sketch the graph to see. All right, let's do 5. So ln is the same thing as saying log. We can change it to be log if we want. Same thing. Our graph starts off by being a sideways exponential graph, but we have to apply any reflections if we have them. Well, we have a negative on the outside, so that's a reflection in which axis? Outside. Reflection in the x. So our x-axis is this one, so it flips along the x, so it'll change to be this. All right, so for our domain here, the key number from our domain comes from setting the parentheses equal to 0. So x plus 6 equals 0. So what does x equal? Negative 6. That's going to be our vertical asymptote, so x is equal to negative 6. But for our domain, do we know if it's going to be negative infinity or positive infinity? Positive, because our graph is pointing in the right direction. So it'd be negative 6 to positive infinity. So again, it helps to sketch the graph so you know negative infinity would be on the left over here, positive infinity is on the right. So our graph is going to the right, to positive infinity. And then what would our range be? Negative infinity to positive infinity.